President Trump says America needs Greenland now. This frozen giant hides trillions in power and secrets. These builds defy minded 60 degrees Celsius ice. The president knows the value.
Patuxent Space Base, America's northernmost outpost, now upgraded to monitor the entire Arctic sky and sea. Runway cleared first, 2 miles long, prepped for heavy jets in year-round operations. New LEDs installed, pierce polar darkness and fog for safe landings anytime.
These LEDs, sealed tight against mighty 60 degrees Celsius, calibrated to guide aircraft perfectly.
River bridge next. Beams flex with permafrost shifts for stable crossings. Heated mix poured quickly. Sets before freeze. Thermal piles chill ground below. Foundations stay rock solid. No sinking as climate changes.
Piles pump refrigerant constantly. Fight heat from above to keep permafrost frozen.
30 meters steel skeleton drilled to bedrock. Anchors against 100 miles per hour Arctic winds. High-frequency drills reach 30 meters plus deep. Vibration stops hole collapse in frozen soil.
Rig conquers shifting ice snow. Solid base for towers that last decades.
A 50-ton radar panel is carefully placed. It's the first piece of an eye that will track threats over the poles. A reinforced dome inflates over the radar, tough enough to shed ice but thin enough to let the signals pass through.
This dome inflates in just hours, creating a perfect, sealed environment for 24/7 scanning, no matter the weather.
A buried power plant is the base's lifeline, housing generators that can run everything if the main grid ever fails.
This underground powerhouse can deliver enough energy for a small city, all through specially protected frozen lines.
Deep below the ice, the brain of the system activates, linking these new radars to a nationwide defense network. There are full backups for everything. If one radar system fails, the view switches to a secondary one instantly.
This total redundancy means zero blind spots. Even in the worst storms, our eyes on the Arctic stay open.
A powerful icebreaker is deployed, its reinforced hull smashing through multi-year ice to keep the port open.
This hull is built like a tank. It absorbs huge impacts, keeping our supply ships moving through these dangerous waters.
The LEDs fire up for the first time, cutting through the dense fog to guide critical cargo planes in total darkness. Welders use special low-temperature rods, creating flexible joints that can resist the immense pressure of expanding ice.
These welds are incredible. They prevent cracking in the brutal cold, so 100-ton trucks can cross here safely.
New barracks are snapped together using modular, super-insulated panels designed to fight off the extreme polar cold. These heated living modules are engineered for total isolation, supporting hundreds of personnel through the dark winter. The new radar begins its 360-degree sweep, scanning the strategic G-Uke Gap for any potential northern threats.
This eye can track launches from thousands of miles away. It literally turns this frozen wasteland into a high-tech shield.
Communication cables are trenched 10 meters deep into the permafrost, insulating them against freeze-thaw damage.
Burying the cables this deep keeps them just warm enough to prevent breaks. The connection will never go down.
Phase 1 of the upgrade is complete. America's Arctic eyes are now stronger and more vigilant than ever before. These thermal piles run non-stop, actively freezing the soil to counteract the immense heat generated by the radars above. The drill holes are lined with steel sleeves and concrete, protecting the tower foundations against shifting ice pressure.
These sleeves create a perfectly steady structure, helping the towers win their constant battle against moving permafrost.
The backup generators roar to life, proving they can power the entire base independently during any potential blackout. The drills here conquered 1,600 feet of permafrost, creating a solid base for all future growth. A torrent of data flows in real time to command centers, creating a unified and complete picture of all Arctic threats.
This network never sleeps. It tracks everything from missiles to satellites, giving us total situational awareness.
The new bridge is tested with a full weight load, proving it remains stable under the combined stress of ice and trucks.
These tests prove the strength of the design. This crossing will be safe for military convoys for decades to come.
The fortress of Patuxent is now unbreakable, but the real treasures hidden below the ice are what come next. Beneath 2 miles of ice lies a treasure trove, 1.5 million tons of rare earths, the elements that power our modern world. Massive drill rigs are moved by tracked carriers, which distribute the weight so these huge machines don't sink into the snow.
How do you drill through frozen rock? With this beast. Its specially heated bits slice right through the ice.
Diamond-impregnated bits cut through the hard ground, while advanced shock absorbers prevent fractures in the brittle ice. Core samples are retrieved every 10 meters, and an on-site lab checks their quality for precious minerals instantly. As the ice melts, it exposes these vast deposits. Engineers are now planning how to access them with minimal impact.
Look at this. These layers reveal the different mineral zones, guiding the drills to the most valuable rock.
New access roads start with a layer of geotextile fabric, which traps heat to stabilize the permafrost and stop it from sinking.
This fabric and gravel combination is genius. It keeps the roads perfectly flat, even during the summer thaw.
Worker camps are assembled in days. These heated modules are a lifeline, protecting crews from -60-degree nights. Foundations must be dug during the brief summer thaw. A special anti-freeze concrete is poured immediately after. A tightly tied steel rebar cage creates a foundation strong enough to support the immense weight of heavy crushing machinery.
This rebar cage is designed to fight seismic ice shifts, holding everything steady under massive, vibrating loads.
In the separation plant, special chemicals are used in flotation tanks to separate the rare earths from the crushed ore. These processing plants are modular, allowing them to expand their operations and scale up as more ice melts away. The giant crushers are mounted on special isolator pads, which absorb shocks so the machines can run smoothly on frozen ground. The pipelines are wrapped with electric trace heating wires, a simple but effective way to stop the chemicals inside from freezing.
These thin trace wires keep the contents heated, ensuring there are no blockages even during the long polar nights.
The conveyor belts are made from a special cold-resistant rubber designed to withstand abrasion from sharp ice over many kilometers. Double-layered geomembrane liners are buried around the site, a critical defense to stop any chemicals from seeping into the soil.
Every single seam is heat-sealed and inspected. We can guarantee zero leakage into this sensitive Arctic environment.
Tailings dams are built with a compacted core and a geomembrane interior, creating an impermeable basin for waste material. They even have engineered overflow weirs, designed to safely handle any sudden surges from melting ice and snow. The deep exploration bores are now reaching over 1,000 meters, retrieving untouched high-grade mineral veins for analysis.
These cores stay perfectly intact. Now our labs can map the exact mineral locations for super efficient mining.
Heavy-lift helicopters are the only way to deliver drill rigs to the most isolated and valuable high-elevation deposits. A hybrid power system is installed. Large solar arrays power the summer operations, with diesel generators for the dark winter.
These panels are angled to catch the low sun, cutting our fuel use dramatically during the 24-hour daylight of summer.
For the winter shutdown, all critical equipment is tented and heated to protect it from -60-degree freeze damage. An on-site XRF analyzer gives instant elemental readings from the drill cores, guiding where to drill next. This constant stream of data drives every decision, ensuring maximum efficiency in the very short Arctic work season. The crushers are skid-mounted, a clever design that allows them to be relocated in just days as the melt reveals new ore. A closed-loop water treatment system is installed. Filtration towers clean and recycle 90% of the water used on site. The road network now extends over 50 kilometers, its insulated layers strong enough to support 100-ton haul trucks. The ore stockpiles are covered with heated, insulated tarps to prevent them from freezing into one giant, useless clump. A network of sensors is buried around the perimeter, ready to detect any potential seepage for an immediate, automated response. This constant, real-time monitoring is how they protect the delicate meltwater ecosystems and enforce clean operations. The small-scale pilot plant runs its first test, confirming that the chemical separation process works perfectly in the Arctic cold. And there it is, the complete vision. As the ice melts to open access, engineers build a lasting and efficient extraction operation.
We've unlocked the minerals, but now the melting ice is creating something even bigger. Game-changing new sea routes.
The ice is in full retreat. The legendary Northwest Passage is awakening, and it's demanding a whole new set of engineering solutions. The Arctic sea ice is down 13% per decade. The fabled Northwest Passage is now open for months longer than ever before. 75,000 horsepower nuclear icebreakers are leading the way, crushing through 3-meter-thick ice ahead of cargo convoys. The hull plating is 50 millimeters of solid steel with double layers designed to absorb impacts from massive icebergs. Powerful thrusters use dynamic positioning to hold the ship perfectly steady, even in strong winds and currents. Ice tracking buoys are anchored to the seabed, sending critical drift and thickness data back to the fleet via satellite. Out here, there are no ports, so engineers are connecting floating pontoons to create temporary deep-water cargo points. Powerful onboard radars are mapping the ice 50 kilometers ahead, classifying its type and danger level for route decisions. Engineers are testing a new air bubble system, pumping air along the hull to reduce drag and stop ice from sticking.
These bubbles make the hull slippery. It's an amazing trick that helps these massive ships move easier through the ice.
At strategic choke points, monitoring towers are being erected, their cameras ready to track all vessel traffic day and night. Heated platforms are being installed on the ships and towers, keeping the sensitive equipment running longer in the melt season. New communication cables are being plowed 2 meters under the seabed, protecting them from being scraped and cut by deep ice keels. Autonomous underwater vehicles are launched to map the channels, their sonar finding new shallows created by the melt. Where there's no dock, engineers build one out of ice. They are thickened by spraying water, which freezes in layers.
This layered freezing creates a solid, stable dock in just a few days. It's strong enough to support a heavy crane.
Dynamic positioning is a game changer. The ship's thrusters can hold it perfectly steady for loading, even without anchors. The system combines GPS and ice radar data to allow for precise station keeping, even in moving ice flows. In key areas, dredgers are deepening the channels, their powerful pumps moving material to make way for larger vessels.
These massive cutter heads literally grind away at the bottom, creating a permanent, deep channel for the next generation of ships.
New wind and solar-powered beacons are installed, their bright flashes guiding ships through the thick Arctic fog and darkness.
These beacons are built to survive minus 70-degree temperatures, providing reliable signals season after season.
All of these systems integrate into one network. Live ice data plus up-to-date charts equals a secure and efficient transit.
The melting ice is opening up a whole new world, and engineers are the ones building the safe way through it.
The bases, the minerals, and the new sea routes, it's one vast, interconnected Arctic engineering triumph. The frozen ground has been conquered, precious minerals are rising, and the seas are opening.
This is human ingenuity versus the coldest place on Earth. What we're seeing here is going to change everything.
Trillions of dollars in value are being unlocked, engineered from solid ice into critical infrastructure, all in real time.
Which engineering feat blew your mind the most? The permafrost drills, the radar domes, or the icebreaker hulls? Tell me below.
Every single detail has been solved, from refrigerant flow to modular design and adaptive hulls. This is pure precision.
If this incredible Arctic build marathon amazed you, hit that like button and share it with your engineering friends.
The future may be coming. What you've seen is a conceptual exploration of what could be, a digital blueprint for a changing world. Subscribe to stay ahead of the curve.